Welcome back. So I wanted to give you all a quick status update on what was going on with JCM-1 for a couple different reasons. One, in my last video, that video was really flippin' long, and a lot of people were saying in the comments, hey, can you break this up into shorter pieces? It's hard to sit down and watch 2 hours of YouTube at a time. And I'm going to take that to heart. We're going to do more frequent, smaller updates. I'm going to break these episodes, which somebody in the comments called chapters, and to some extent they were kind of like chapters. We're going to break the chapters up into sections, so we might have an episode 8.1, 8.2, 8.3, 9.1, 9.2, 9.3, something like that, and have more frequent, smaller updates. Additionally, I'm going to be going on I don't want to say vacation. I almost said vacation. I'm going to be going on a work-related conference travel thingy next week to Nashville, Tennessee. So I wanted to give you guys something to look at while I was gone. So let's get into the what I've updated with JCM-1 since we last talked. Not a bunch of changes, just a few little things, but they're important to note for next time. First off, I cleaned up and rearranged the code in the BIOS/monitor ROM to work a little bit more logically. I clearly separated what I think the BIOS calls and monitor calls should be. I think that the BIOS should be, those calls that are hardware specific to JCM-1 design that other applications can use. If this were a Mac or like something like that, you would call them the toolbox ROM or whatever. Those frequently used routines that you can use in your code and just call, and the computer will do what it needs to do to simplify your own program. And then I separated that from the BIOS calls, the monitor calls, the monitor programming being that, the monitor, so you can type in code and enter things like that. I don't think that those should be intermixed. They were kind of intermixed, and some calls, it would go like monitor calls, then BIOS calls, then monitor calls, and it would be all intermixed. I separated all that out, changed the reset vector to point to the right spot, all this other stuff. So that's all been cleaned out and separated. I cleaned up some loop naming to make things a little bit easier to understand if you're looking at the code. Using some tricks of the assembler I'm using, plus just renaming things. I also renamed all of the subroutines in it to make it clear what's a BIOS subroutine and what's a monitor subroutine. BIOS subroutine starting with B underscore, and monitor subroutine starting with M underscore, to make it a little bit easier to see what's doing what. I improved code here and there, nothing major, just tiny little tweaks. I read back through it and I saw, well, that doesn't look good, or that's not efficient, or this or that or the other. The biggest thing was the BIOS calls for sound. So the BIOS has two sounds built into it. One is the startup chime, the bing noise, and the other is the beep, the ding, or the bell sound. Those two were they were hard-coded as a series of data stores and subroutine calls in order. Very space inefficient, so I changed that to a generic reusable routine along with a database. So it uses register indexing to just fetch out of the database in order and smack all of those registers on the sound chips straight out. Saved something like, I didn't do the math, but it's something like about a page of memory. It saved about 256 bytes of memory. It was kind of crazy. Cleaned up the code formatting, yes. So the code formatting in it had weird different spaces of indents, and different routines, depending on when I wrote them, would be tabbed over different amounts, and how I wrote the comments on each of the lines and routines was a mess. So I went through the entire thing and rewrote all that, so it's a nice, clean, straight read. It's all consistent throughout. I noticed one issue with the print hex routine in the monitor. So the print hex routine, what that does is that will take the value in the A register in the accumulator, convert it to a 2-character value that is you call it the written representation of that byte. So say the byte has a value of 127 in it. It converts it to 7F, right? Instead of being 1 byte, it converts it to 2 characters, and then it prints it to the screen. That routine heavily abuses fall-through, so that when it is done, it drops straight into the serial output routine to send that character to the screen. And the problem with that, you might already be able to see the problem with that, is eventually serial output is not going to be the default input and output for JCM-1 anymore. So that fall-through is going to be a mess. As you could see from the keyboard portion of the project, I want to change JCM-1 eventually to where all character input and output goes through a vector, which then goes to a routine. So this fall through is not going to work properly in the future. I just have to note that, so that when we do that, I'm not chasing weird, code ghosts for, hours. Additionally, I noted future issues with character outputs. So right now, the character outputs, how can I put it? Every place where the BIOS or the ROM or whatever sends characters out to the screen is formatted using ANSI, ANSI characters, so screen control codes and all of that stuff. So because I'm working with it through the serial input and an ANSI compatible terminal, I need to have ANSI compatible screen formatting. Well, again, eventually, JCM-1 is going to have a graphics-based character output screen thing, like a million other computers of the era we're trying to emulate. And when we do that, it's just going to spit a character to the screen at the current screen location. I'm going to do a little bit more specific control of where things are on the screen. And so that character input output routine needs to not be dealing with ANSI characters anymore. So we'll have to deal with that, strip that out, but be aware of that, because I'm not doing anything with that right now, obviously, but when we get to the point of dealing with that character-based screen output, like a TV or a RGB output or whatever, we're going to have to deal with that, because that's not going to be ANSI. It's going to be hard-coded character whatever, I don't know if I explained that very well, but basically ANSI's going to have to go away, and I'm going to have to rewrite a buttload of code all over the place, because I'm assuming ANSI output all throughout the code. I wired in the CS-NOT chip, the chip select NOT kit. Let me start that phrase over. I wired in the chip select NOT, a negate chip, or a inverter chip, to eliminate the I/O cell line. And then I've already also updated the schematics to reflect that. Basically, the CS-NOT chip was originally an inverter that was for the potentiometers for the sound chip. And there was a space wired on the board to stick it there and this, that, the other. But I didn't put it back in because I figured I didn't need it, and I talked about that. But then came back around and realized that, well, if I add that back in, I can eliminate the I/O cell line completely, because I won't need that anymore. It doesn't even need to be there. I can eliminate that from the memory mapper ROM, and then have one more memory mapper outputs available for dealing with whatever chip I want to deal with, or dealing with extra I/O space, extra peripheral address mapping, whatever. So I put that chip back in and eliminated I/O cell to give me more space on that. I don't know if it'll stay that way. This project is it goes this way, then that way, then this way, then that way, and that's just how these design things works. As you play with something, you think one way is a good way, then you change it because the other way ends up being the good way, and whatever. I wired in a 74LS00 NAND gate to the phase 2 and read-write lines on the 6502, in order to create clean read and write lines for RAM and ROM, and then I updated the schematic to show this. Now, why did I do this? Because that is the standard paradigm for gating the read-write line. On the 6502, it really does not want data on the bus before phase 2 comes high for lots of many reasons, for ringing and inductance and chip setup times and gate delays and all this other stuff. It does not expect the bus to have anything on it before phase 2 comes high. Basically. The computer was running fine for the most part without having gated that at all, but the moment I put in some weird chip, it might have a problem with that. The 6502 might have an issue with that. Who knows? So I went ahead and wired that back in. It's up at the very top of the board, labeled RW map, to help us make sure that read-write line the read-write line select to the other chips are only selected at the right time, basically. I found out that after I put that in, JCM-1 became stable without the keyboard disconnected. So before that, if I had the keyboard ribbon cable disconnected, JCM-1 wouldn't boot up correctly, and I think it was because the bus was floating during a period of time while it was checking to see if the keyboard was there to do the keyboard initialization or whatever it was, and it didn't like it. It would make the sound chips do weird things, basically. It would work fine immediately after reboot, and after it sent sound to the sound chips, it would be fine after that. But sometimes it would do the same thing as it did when I rewired everything. It would make the sound chips go and just stick there and whatnot. But I found after I put the RW mapper in there, that NAND gate, it was fine. I can run it with or without the keyboard connected, and it's like, okay. So that I think that's going to clean up any potential pitfalls or issues down the road with the system doing weird things that I can't understand. That's the main stuff on JCM-1. Now, I went back to the keyboard and just did some cosmetic fixes to the way it operated. First off, the keyboard input routines, when switching from one to another. So when I was switching from serial to keyboard or keyboard back to serial, I wasn't clearing their buffers. So their buffers might have been in a weird state from the previous time they were activated. I think we saw this in the previous video. When I switched back and forth, there would be a letter in its internal buffer, and then it would show it to the screen because JCM-1 thought there was a key there. When switching between those two, I now clear the buffer out before coming back from the initialization of switching to either of those input devices, and that fixed that problem. The character ingest routine, the routine where I would hit I0 or I1 to change whether we're coming from the keyboard or from the serial port or whatever. I had thought I had programmed that to accept only a 0 or a 1 and everything else would cause an error, but apparently I had a goof in the code and it would accept anything. If it was wrong, it wouldn't do anything wrong. It wouldn't break, but it wouldn't tell you that you did it wrong. So I changed that. So if you say I2, which right now is not a valid input, it'll go it'll throw an error on the screen, so you know it's not working correctly. I discovered a floating address pin on the keyboard mapper that the sloppy read-write stuff, by not having read-write gated, was masking. So when I added RW in, I found that the keyboard would start barfing random crap at JCM-1, and it didn't make sense to me. And I looked very quickly and looked at the back of the keyboard mapper, and I was playing around with it, and I found that one of the address pins I had missed, and I just didn't ground it. Oops. No floating inputs, remember. Chips don't like floating inputs, so I just grounded that real quick, and that solved that problem. The microcontroller on the keyboard was loose in the socket. I just doubled the socket up. I don't know what it was. If you push on it, sometimes it would send random crap out the keyboard to JCM-1, and it would show stuff on the screen, whatever. But whatever. I just doubled the socket up to fix that. Of course, these are just temporary fixes. Eventually, the keyboard is going to get a nice, new, clean design. Told you a little secret. So yeah, I'm not quite sure how I'm going to do that. I'll get back to that in a moment. The delay between when you press down and hold a key and when it started repeating that key was a little bit longer than I liked. So I shortened that a bit. It was set to wait for 60 cycles, and then I think I had changed other code that made each cycle take longer. And so between demo, the previous demo, and now it got too long, so then I went back and shortened it back up. So it's about a second, you hold it, and then it starts repeating. It feels right. The key repeat itself was also slower than I liked. It was taking too long between repeats to fire out a character. Did the same thing, I just shortened it up a little bit, and that solved the problem. And the key bounce test, I had that set to something like 10 milliseconds, and that felt way too long. It felt like if I typed at the keyboard really fast, it would miss things. So I cut that in half to 5 milliseconds, shortened it up, and it seems to have still solved any key bounce problems. There is no key bounce. You press a button once and it does it, and it's fine. And also, I can type at the thing like mad, and it doesn't lose keys. So that is a good thing. What else is going to be coming up? We already talked about that in the last video, doing a video generation. I have already started on oscillators on that to figure out the timing. This is a 28.63 megahertz oscillator that I just happen to have in a grab bag of random oscillators, which is twice the master frequency of NTSC, which is 14.31181818. And then I'm using a couple dividers to divide that to 14, 7, 3, 1.7, so on and so forth, that I can use for NTSC output. So I've already started on that a little bit. I also got a couple of extra microcontrollers of the same variety that's on the keyboard so that I can play around with what I would need. Again, these microcontrollers are probably way overkill for what I need to do, but I already have a programmer for it. So yeah, we'll start there. Again, these are also cheap. They're like $1.38 in bulk, so I'm not really worried about the cost. Now, I could get the cost way, way down by using more of these, but more cheaper ones, like little 20-cent microcontrollers to do one to do the timing and one to do pixel generation, this, that, the other. But you know, we'll get into that as I move forward. I may not end up using those chips. We'll see. And then back to the keyboard real quick. I mentioned I was going to talk about this. I've been thinking about ways to make the keyboard more permanent. If I want to put this, put JCM-1 together in some sort of permanent fashion, how am I going to make keyboards for that, right? So I'm thinking that this keyboard layout here, I will show you. This keyboard layout for JCM-1 right here is effectively what's called a 65% keyboard layout. It's not exactly, but it is really close, and it's close enough for what I'm doing. It's only missing a couple keys that the 65% layout is missing, and I can just use those to make, I don't know, special function keys, something that does something later, whatever. I'm thinking that I can get a 65% keyboard layout kit and put it together, but not use the PCB, because the PCB is going to be one of these make your own keyboard kits. The PCB that comes with it is going to be pre-wired to be basically a PC keyboard, right? But I don't need that. I need to manually wire up my own thing on the back to do that. So I figure I can get the whole kit, put the whole kit together, keep the PCB out of it, but somehow affix the key switches to the metal frame that they lay in using epoxy or glue or something, hopefully something non-permanent, but we would see, and then flip it over and wire the columns and rows, and then have a little board, if I can get one out. I have one, have a little board, something like this, that has all of the, maybe a little bit larger than this, that has all of the electronics on it, that then connects to the keys to the outside world. I don't know, I'll figure that out. But that's what I'm thinking on the keyboard. I hope you liked this little update. If you did, leave a comment, subscribe, hit the bell, do all the YouTube-y stuff. Remember, I got a Patreon, link in the description if you like what I'm doing. Donate to the channel. It helps me keep doing cool stuff, keep building interesting things like this, and helps me keep the racks full. Well, that's all for today's episode. While you're here, check out some of my other videos. And remember, 8 bits are all you need.